Okay, here's some more integration problems. Here we're doing substitution again, but this time it's called double substitution. And you'll see why in a second because we're actually going to substitute twice. Let me turn my pen on here. So there's clearly an inner function of 2x minus 1 inside of this radical sign here. We have this other x outside here, and what we'll do is we'll just change this x to be in terms of this u substitution we did here, and then we'll be able to integrate everything with respect to u. So the first thing we should recognize there's an inner and outer function, so therefore the inner function is 2x minus 1, so we're just going to let u equal 2x minus 1. So du is 2 dx, so du over 2 is equal to dx. Now notice if I do my substitution here, I get x, the square root of u, and then du over 2, so I have x and u, and that's bad, so therefore I want to see if I can get rid of this x. Well, I can do a pretty straightforward substitution here, solving for x, so I can get rid of my x here. So I'm just going to take u equals 2x minus 1. I'm going to add 1 to both sides. So I get u plus 1 equals 2x, and then multiply both sides by a half, so I get 1 half u plus 1 half is equal to x. So now I'm going to replace x with this little mess right here, so I get the integral of 1 half u plus 1 half times this radical u, so I'll write it as u to the 1 half, and then this du here, and I'll just put a 1 half up front. And also, since there's two 1 halves here and another 1 half here, I'm going to put that 1 half up front. So I'm going to get 1 quarter u plus 1 to the u to the 1 half du. Now this is just old school integrals here, where you just distribute the outer function inside the parentheses. So I get a quarter, I get u to the 3 halves plus u to the 1 half du. And now I just integrate this, adding 1 to this gives me 5 halves multiplied by 2 fifths plus u to the 3 halves multiplied by 2 thirds, 1 quarter on the outside, plus c. So this gives me, I multiply a quarter times 2 fifths gives me 2 twentieths. U to the 5 halves plus a quarter times 2 thirds is 2 twelfths. U to the 3 halves plus c. And then I can simplify this over here, so I get 1 tenth u to the 5 halves plus 1 sixth u to the 3 halves plus c. And now the next thing I want to do is I want to make these two terms look a little more attractive. I want to get a common denominator between 10 and 6, which would be 30. So this would be 3 tenths u to the 5 halves plus 5 thirtieths u to the 3 halves plus c. And now I'm going to take out a common, got a little crazy there, take out a common denominator, a common factor of, this should have been 30 here, take out a common factor of 30 and u to the 3 halves. So this is 1/30th u to the 3 halves. If I take 3 halves out of 5 halves, I just get u, so it's 3u plus 5 plus c. So I just took a 30th and u to the 3 halves out of this. I'm just left with 5. Now I know what u is. U is, because I want to remember my answer in terms of x, I know my u is 2x minus 1. So I can rewrite this as 1/30th 2x minus 1 to the 3 halves 3 times 2x minus 1 plus 5 plus c. And this 1/30th stays up front. So that gives me 6x minus 3 plus 5 plus c, and that's 1/30th 2x minus 1 to the 3 halves 6x plus 2 plus c. I can take a 2 out of this, so this gives me 2/30th 2x minus 1 to the 3 halves gives me 3x plus 1 plus c. Then I simplify this, I get 1/15 2x minus 1 to the 3 halves 3x plus 1 plus c. So the textbook, this is the most simplified answer that you want to have, so we want to shoot for that. So the trick really was, before you do, after you're done with the integration over here, you want to get a little common denominator and then take out the greatest common factor that's concerning the denominators, as well as these u terms here, and then sub u back in, and then just do a little algebra and a little factoring, and then here's your much more attractive looking answer.